Okay, so let's move to the next problem, which is this. Okay, so this actually is the reverse question. What is that? What is the question here? For an LTA system, frequency response is given. We have to find out the linear constant coefficient differential equation. Okay, yes. So let us write down this in a nice way. So h of j omega, we can write it as j omega plus 4 whole divided by, so I will write it a nice way. So that is j omega whole square plus 5j omega plus 6. Okay, yeah. So with that, first step is we have to factorize this h of j omega. We factorize the denominator, so you get j omega plus 4 divided by denominator, we can write it as j omega plus 2 multiplied j with j omega plus 3. Okay, then yes, so we get this, and I think this is not necessary for finding the frequency response. Okay, so let us do this later. Okay, so what did we get? H of j omega, we got that to be j omega plus 4 divided by j omega whole square plus 5j omega plus 6, and this we know that is equal to how much? Y of j omega by x of j omega. Okay, so let us do the cross multiplication. So what do you get? You get j omega whole square multiplied with y of j omega plus 5j omega y of j omega plus 6y of j omega would be equal to j omega x of j omega plus 4x of j omega. What is that we have done? We have taken the cross multiplication. Now what we'll do, we will take the inverse Fourier transform. Okay, so taking inverse Fourier transform. Okay, so taking inverse CTFT, we get what? So j omega whole square y of j omega means you get d square y of t divided by dt square plus 5 times dy of t by dt. Correct? J omega y of j omega means you get d by dt of y of t plus 6y of t is equal to, this fellow should give you d by dt of x of t plus 4x of t. So that would be the linear constant coefficient differential equation for the given frequency response. Okay, so next question is find its impulse response. So to find the impulse response, you have to take just the inverse Fourier transform. Here that partial fraction expansion will come. Okay, so let us write down again h of j omega, which is j omega plus 4 divided by j omega whole square plus 5j omega plus 6. So as said before, we can factorize the denominator. We get j omega plus 4 by j omega plus 2 multiplied with j omega plus 3. Okay, so that would be the factorization of the denominator. So if you do partial fraction expansion, let us do that. So we have j omega plus 2 in the numerator. If you replace j omega with minus 2, what will happen here? Denominator is 1. This fellow would become 2. So you'll get 2 by j omega plus 2. And again, if you replace j omega with 3, minus 3, you will get 1 in the numerator by minus 1 in the denominator. So you will get minus 1 by j omega plus 3. So this implies what will be the impulse response now? H of t would be equal to, which signal will have 1 by 2 plus j omega, e power minus 2 t u of t, and that is multiplied with 2. So you will get 2 e power minus 2 t u of t minus this fellow will have e power minus 3t u of t. So that would be the impulse response of the corresponding LTI system. So next question is we have to find the output of the system for the given input. So I will put two steps, remaining we will take it as homework. So what is our y of t here? Y of t is nothing but x of t convolved with h of t. H of t we got it here, so let us substitute everything whatever we have. X of t is given to be e power minus t u of t minus e power minus 2t u of t. So this is our x of t, and this fellow should be convolved with h of t. So h of t we got it to be 2 e power minus 2t u of t minus e power minus 3t u of t. Okay, so that would be the h of t. We got the result above. Okay, right. So this we will expand it out like using what property? Distributive property. You will get e power minus t u of t convolved with 2 is there, you'll keep it out. 2 e power minus 2t u of t, that is first term, minus e power minus t u of t convolved with e power minus 3t u of t, that is the second term. So what is that we are doing? We are convolving this with this whole term. Okay, you get two terms in this, and again now we will do e power minus 2t u of t convolved with again this whole term. So you will get minus is there, be careful. So you'll get minus e power minus 2t u of t, again 2 is there here, so that will keep it out, e power minus 2t u of t, and what is the next term? You get plus e power minus 2t u of t convolved with e power minus 3t u of t. So these results we already know. So just substitute everything and please give it as the homework. Let us take that as homework. Final result. Please bring the common together, to common terms together, and then make it very compact. Okay.